welcome, and thank you again for tuning into the third episode of the Political Inaccuracy Podcast. I am your host, Jimmy Sullivan, and alongside me today is Deaglan DiMurro. Our last show, we had Connor DiGiacomo with us. He is not with us today. Not to worry, he is just fine, but he was unable to make it today, so it's just me and Deaglan on the show today to discuss a variety of topics.
That indeed.
Yeah. So our last show, we left off talking. We started a conversation on space travel, and we basically left it on a cliffhanger.
Briefly. Yeah, we talked. Well, we talked about. I think we had said, we ever think we're going to get to the point where, or maybe we will need to leave the planet. And we all kind of, obviously agreed upon the fact that we don't want to get to that point.
No,
that's not ideal.
Better not be in my lifetime.
Yeah. Yes, but it might happen.
Yeah,
eventually, down the line, it might happen. I think we all kind of came to the agreement that you have to admit what we're doing to this country, even excluding stuff, like warfare and all that stuff, just what we're doing to the country and to the world and our environment and stuff. You might say that, something like global warming, isn't as true as scientists say, human-induced global warming, yada, yada, yada. And say that if you will, that's fine. But, you can't say that what we're doing is good. You can't say we're helping our planet at all.
Yeah, and it's like you just said, while, you could think whatever you want about global warming, how serious it is, how big of an issue it is, whatever, but you can't say that just throwing carbon emissions into the air is good for the planet. It's like if you go home and you just eat a bag of chips a day.
Right.
Like eventually, if you do that long enough, you're going to die. And and if you don't exercise and all that.
And even if you do exercise, and even if you're a very healthy person, you can't say that it's good for you.
No.
Sure, it might not be hurting you all that much, but it's not good for you.
No.
Right, you're not helping yourself, and that's I think the point is we're not helping ourselves, and so eventually probably we'll get to a point where, and you had said last time that the world, the Earth, we're still here. It's done a very good job taking care of us so far. And I hope it will for another long time, but the fact of the matter is that will most likely eventually sometime down the line run out. So the question is, then what?
Yeah, and that's kind of the main question we're going to try to answer today is then what? If we ever get to that point, God forbid, where this Earth is just so screwed up that we got to go, can we send people to another planet? Can it be inhabitable? Can we find out enough about that planet to be able to send them to that planet, etc.? So we're going to have a very interesting discussion today. And, so Deaglan, if you want to start on that kind of train of thought, which you started, but I don't think you really finished there with the whole sending people out of this Earth. We had started talking about it the last time.
Yeah, sure. So, really the questions that come up are, first of all, is it possible? Second of all, is it practical? And then I guess really, third of all, how would we go about it? What is the most pragmatic? I guess that would be the last one. We'll stick to 3 Ps. Is it possible? Is it practical? And then is it pragmatic? Or how can we do it the most pragmatically?
Yeah.
So obviously I'll just kind of summarize each question and then we can go into them individually. But is it possible? Can we do it? Is there actually a way to do it? Obviously, we could put men on the moon. They're proposing we can have men on Mars, I think by NASA said like 2030. I think SpaceX wants to do it by the 2020s.
Yeah.
So that's probably possible, but neither of those places, at least as of yet, seem, all the best for inhabiting human life. So if we're talking about somewhere that can inhabit human life, we're talking more of the likes of NASA just recently discovered the TRAPPIST-1 system, which seems very promising for that purpose. So is it possible? Is it possible to get there? Second of all, is it practical? Will it be worth it? If by the point that we know that our Earth is doomed, are we too late? Is it too far to get to wherever we're trying to get that we can't do it? Is it practical? Or would we have to send people now, in which case people might argue, well, then it's not all that practical, because suppose we send people there, and then they end up, stuck out there. Turns out we don't need to go to them anytime in the near future. So we're not going to. They're left alone out there. Is it practical in that sense? And then the last one, is it pragmatic? And I guess what I mean by that is not so much is it pragmatic, but how do we make it pragmatic? How do we do it effectively? Do we do it as a world, as a planet? Do we send like half of the human population out there? You know, if we can at that time, if it is possible to do we do that? Do we send a small team out first to explore? Do we, you know, as a nation, do we fund it on our own, or do we try to get the entire planet involved? Like, what is the process? You know, will we have one day just one country at a time? You know, one day Canada decides, all right, we're out of here, and Canada, the entire country of Canada, leaves, and then there's just nothing in Canada. And then
does that mean it's ours?
Probably, I guess. Yeah, it'll be ours or Russia's. And
the parrots are at home. We could take the land.
Pretty much, yeah. Yeah, that's how I would do it.
Yeah.
But and then you know, a couple of years later, Ecuador's like, yeah, you're looking pretty good up there, Canada. We're gonna come join you.
Yeah.
And then Ecuador's do we leave one country at a time, whole planet at a time? People at a time? Do we mandate it? Is it a forced leave, or do you have the option to stay? If it is a forced leave, is it something that you can do via your government? Is it pragmatic? How do we make it pragmatic? What is a pragmatic way of going about it?
Yeah, and you know, I kind of wrote down everything you said. I'll kind of go in reverse order. You know, how do we make it work in terms of just with the United States or with NASA or with SpaceX or with other countries? It's obviously different from in the 60s when there was this huge space race, right? We wanted to be the first people on the moon for America. We didn't care about collaborating with other countries. Now, collaborating with other countries could have made it easier. And I mean,
without a doubt.
Yeah, and we might have actually in the process, but we wanted to do it simply for the United States of America. Another thing you raised is the mandate, whether it's in 100 years, 1,000 years, 10,000 years. I don't know if governments would be able to mandate, you know, their citizens just...
You think about it, governments do have, and they've had before, mandated evacuations of cities.
That's true.
If there's a disastrous event incoming, you know, whether it be tsunami, tornado, volcano, anything like that, they'll mandate the evacuation of a city, and when they do that, If you stay, you can get in trouble. There's consequences for that. Could we, in a sense, use that same logic and say, well, look, if you stay here for this reason, or that reason, you know, you're going to probably die. Yes. So thus you have to come. It's a forced mandation, or forced mandation. That doesn't. It's a mandated evacuation. There we go. Forced evacuation.
Yeah.
That you leave. Can we do that? And then also, I figure I'll just bring this up now because we talked about it in the last episode. Absolutely go check that out if you have not already. Globalization. They determine there's a meteorite headed for Earth, and there's nothing we can do about it. Yeah. Because if they were to find a meteorite like that, what are we going to do?
Yeah.
Launch a nuke at it? It's not, unfortunately, not that easy.
Yeah.
So it's probably a better possibility we will work with each other. But again, still maybe not.
If we get to that point, too, and if we're that desperate, I don't think it's going to matter. I think we're going to say we need to get the hell out of here, and we'll work with whoever, and it doesn't really matter, but we got to get out. If that ever comes, I mean, we're going to get to the point where it's going to be like, you know what, we got to get out of here alive. And whatever nationalistic feelings, whatever global feelings we have towards other countries, those are going to go so far out the window if we're at that point, like in the world, and we're just going to say, you know what, that's fine. Just let's go.
Any sort of space agency. You take a country like, as far as I'm aware, Canada doesn't have one. I don't think England has one. I don't think France has one.
Well, most countries don't.
We're close to practically losing our own at this point, with NASA being cut so heavily.
And you made another point, too, which was important. I think government funding is going to be key, because if you look, NASA, I don't think is getting the funding that it used to. You know, SpaceX is kind of coming into its own, but they might not yet have the resources. I know they're trying to try to put somebody on Mars in 4 years. With future administrations, in terms of research, discovery, are certain places inhabitable if we need them, just in case? And
absolutely. I have no doubt in my mind that NASA could have put a man on Mars in the 70s. Our last moon mission was in 1972, right? If you think, we went from the first true rocket-propelled airplane was developed in, I want to say 1942-ish. I'm sure I could look that up in a second. But I know the Germans worked a bit on rocket technology, and they made their V-2 rocket. Actually, that may have been before their plane. So if we went from not having rocket technology then to putting a satellite around the planet in 1957 to putting a man on the moon in 1969, I have no doubt that we could have been to Mars in the 70s if, I forget who said this, but somebody had said that NASA would have put a man on Mars. We would have already had men on Mars if the Soviets made it to the moon, because it was always about one-upping the Soviets. They started launching a lot of rockets, proving that they could get into orbit pretty successfully. We did the same, but we said, look, we need to one-up them. We need to have something that they don't. We put a man on the moon. In fact, I think we put, Apollo 11 to 17, I think 5, because then 13 didn't quite make
13
it.
yet.
Right.
Yeah.
So
13 wound up being a really good movie.
Oh, that's a great
That is a
movie.
great
Yeah,
movie.
yeah.
Yeah.
Gotta love Tom Hanks.
Oh, yeah.
But we had 5 missions to the moon, and the Soviets never went. So we just called it there. But if the Soviets went to the moon, then we would have had to one-up them. How do you one-up the moon? Mars.
Exactly.
And I honestly think we could have been to Mars in the 1970s if the want for it had stayed, if there was that drive. But no, and NASA's budget's been going down and down and down. And another great thing that you'd mentioned too is, if we're talking about some global disaster, NASA, I find that I don't think a lot of people know this, but NASA's mission now is almost exclusively climate, researching the climate and weather patterns and stuff like that. And obviously, if there's going to be some sort of, climate-based disaster, that's where we're getting our warning from. We're getting it from NASA. And so with all these cuts, it's not looking too good, in that regard.
Yeah, and that's the thing too, because not only is the government going to be important, people's interest in it is going to be important, because people, I don't think people realize just how much cool stuff has come out of NASA. Like, they discovered Velcro, they came up with a whole bunch of other inventions just from research.
We wouldn't have computers if it weren't for NASA.
Exactly.
The government first saw a real need for computers in going to space.
Yeah.
We wouldn't have anywhere near the amount of calculator technology we would, because again, that's what.
Yeah, I mean TI-83. I mean, that's all on NASA.
Right. Yeah. Texas Instruments. Exactly.
Yeah. I just wanted to bring up something you brought up real quick before.
Sure.
List of countries with space agencies that have a launch capability. The list is pretty short. It's China, Iran, Israel, Italy, North Korea, South Korea, India, Japan, the U.S., France, Ukraine, Russia, and that is it.
So France does
so
have
it's
one,
pretty,
right.
it's pretty short, that list, and it's some of the world powers, but not all of them. There's some notable absences, as you said, England, Canada, Mexico, among others. So that's interesting. If we do get to that point, those are probably the countries we'd be working with for right now. If this meteorite comes, tomorrow, God forbid, which I don't think it's going to happen, but you know what I mean. Yeah,
that's true. I'm sure if we're talking, a while in the future, I'm sure other countries will eventually develop.
Oh yeah.
Some form of space. Even if not a government space agency, I'm sure privatized space agencies will become more popular. Not just yet, but maybe in decades to come.
Yeah,
they'll start to become more and more popular as we start to find more commercial uses for space and whatnot.
Yeah, and I think one of your questions too is this worth it? And I think for that reason alone, the commercial reasons, what we can get out of it, I think the answer is absolutely yes.
All right, yeah, talking about computers, calculators. I mean, you think that radios too. We would not have cell phones.
Yeah.
Well, first of all, because we need satellites for cell phones, anything like that.
Yeah, exactly.
The computers we're using right now, sure, we need satellites, but not even that.
Yeah.
Just the idea of radio communication, while we did have it in, I want to say since the 19-teens into the 20s, 30s, obviously we used radios and whatnot, like during the Second World War, but they were to nowhere near the capability we have now. We're talking where in 1969 we could talk, somebody from Houston could talk to somebody on the moon via radio.
Yeah.
Right? And just think about how even infinitely better they are today.
Yeah.
All sorts of microwaves.
Microwaves, yeah.
Microwaves. We would not have microwaves if it were not for space exploration.
Yeah, and I mean, you think about just how different our lives are with this whole internet and everything like that we wouldn't have. without NASA, like before you were saying somebody could
We wouldn't
call-
have this podcast.
We wouldn't have this podcast. Yeah, exactly. But like you were talking about, somebody calling from Houston in 1928 to the moon and thinking like that's crazy. Now, I can turn on my computer, type in a thing that, plays random music for me, from a signal from outer space,
Right.
and I don't even think anything of it. Like
Exactly.
it's just our lives are so totally different and better, especially in the last 40 years or so from NASA, because of all these important contributions that they've made. And so the funding for it, I think, is going to be extremely important in the future. And that's not even really a Republican or Democrat thing. That's just the need to see that this is something that's important and this is something that's made people's lives better, even if some of the missions were not successful, even if they're not perfect, and they're not. NASA is not perfect, but
No.
this is something that has improved the lives of basically everyone on Earth. I mean,
Right.
It really has. And so I think that's going to be something that's important with the funding and everything else that goes along with it, that the government's really going to have to step up on in the next few years.
Right. And so I think this was a pretty good just sort of like intro conversation, really to what all of this is about. So I guess really to just to kind of get back on track with these questions, I guess we'll start off with, first of all, we said, is it possible?
Yeah.
And so, I mean, I'll ask you that. Do you even think, first of all, say today, we'll say today, and then we'll say in 50 years, and then if you want to talk 100, we can, but I think I'd say first today,
Yeah.
and then in 50 years.
That
We're
makes more
talking,
sense,
2060s.
Yeah.
Yeah.
So if we fast forward to 2067 right now.
Right. Well,
can
first start with today. Is
Today.
it possible?
It's not. I think it's possible today. However, I don't know if our necessarily level of knowledge of some of these planets and how inhabitable they are, I don't know if it would be safe to send people up there right now. Like if we said we're going to send people at 8 o'clock tonight.
Right.
Do we do that? I don't know if our knowledge of it, of these planets, is really good enough for us to comfortably say we're going to send people here and they're going to come back and they're going to be able to live and coexist and all that. However, your question about 50 years, I think it's absolutely possible in 50 years, but we need to commit. We need to commit funding.
Oh,
We need
absolutely.
to commit time.
And we need to start now.
And we need to get going.
Yes.
Because I mean, even though we put a man on the moon in a relatively short period of time, but this is a different ballgame. I know we have better technology and all that, but Mars. I mean, if we send a person to Mars, I mean that's not easy, or TRAPPIST-1 like you were saying before, something like that. I just don't see us being able to do it right away. It's going to be a long process, but we need to commit time, effort, most importantly money to this so we can fund it. If NASA and SpaceX decide to work together on it, great, because they're both great people. I mean, Elon Musk has done a great job with SpaceX.
He's a phenomenal human being.
My dad actually came up to me yesterday.
Yeah.
He was like, my Facebook memory, I shared this article from 6 years ago about this guy in California. He wanted to start a small space agency. And I said, oh, that's Elon Musk. He was like, yes.
Yeah, and now he owns electric cars.
Yeah, and now he's, now he might run the world.
Yeah.
But
Getting close.
Yeah, they've done a great job with that. So if they collaborate on that, the better. But it's going to be a long effort. We need to start sooner rather than later. Right now is most preferable, obviously. And I think if we do that, it's very possible in the next 40 or 50 years.
Right.
I think that's what I would say with that. But again, as I said, it's not going to be easy.
Absolutely.
It's not going to be easy. And we may need the help of other countries as well.
Yeah, absolutely. And I think what also people don't understand too is really what we're preparing for is, it's not like we're going to send out a mission to go to a place like TRAPPIST-1, and that technology that we have then is what we're really using in a sense, because we need to prepare for decades in advance for a mission like that.
Yeah.
Now, just going to the moon, that takes I think 3 days to go to the moon. To go to Mars, I want to say a few weeks. I'm not exactly sure.
It's definitely a lot longer.
I would say a few weeks, maybe around a month to get to Mars. I think you're looking that up now.
Yeah.
Yeah, it'd be nice. What does
Okay,
it
here we
say?
go. So I'm going to say that we're going to trust this site. It's called Universe Today.
Okay. Yeah.
Okay, let's see here. How long does it take? It would take the total journey time from Earth to Mars takes between 150 and 300 days. So you're talking probably.
Oh wow! So
it's long. I mean, you're
geez.
talking about half
Yeah,
a year
yeah, that's
at least.
So they're saying at least 6 months.
Probably,
possibly up to a whole year. I wonder what they use to make that. That's because that's a pretty wide margin.
Yeah, and I mean, there
I guess
obviously
it depends on the rocket ship or.
There's a lot of variables. There's the ship.
I
There's
guess
weather.
What we're carrying.
Yeah. For example, Mariner 6 in 1969 launched on February 25th, reached the planet on July 31st. So you're talking a little over 5 months there. That's not a short period of time. And then Mariner 7 only required 131 days.
Right. Yeah. And so you're thinking there. I mean, we're talking. Apple comes out with a new iPhone every year. So if people have to try to stay up to date with that technology, imagine if you're sending something. I mean, not even to Mars, but we're talking like, to a different galaxy.
Yeah.
TRAPPIST one. I don't know per se if it's in another galaxy. That I'm unsure of. But I mean, to a different solar system is my point. Very, very, very far away. You need to make technology that will last and stay functional.
Yeah.
With whatever you have when you launch it until it gets to where it's going.
Yeah.
Because if you think about it now, we have, I know I still do, have chargers that Apple had, a few years ago that don't work with the new technology anymore.
Yeah.
And so, basically what my point is we need to make sure that what we build on that ship is going to be compatible with whatever we develop in the next 100 years.
Yes.
And that's not an easy thing to predict.
Exactly.
Especially when we're innovating more than ever.
Yeah.
And so that takes innovation in its own right.
Yeah.
In order to come up with something like that. I mean, honestly, if you think about it, what's the only... there's one thing, I think, that I can think of that has stayed relatively consistent about what we use for over 100 years.
Pen and paper.
It's very basic. Sure, we still use pen and paper, but
where are you going with this? This is interesting.
Even to say, pen and paper, you can't really translate that so well onto a computer. You'd have to scan it, take a picture of it, upload as a PDF. You can't really translate it nicely to a computer. I was thinking about this earlier. Old photographs, right? Think about how if you want to get an old photograph on a computer, you need to scan it. They weren't stored digitally. There was no such thing as digitally.
Yeah.
If you're talking old photographs, so you have to scan it, right? And I thought about that. It's like, well, when did the whole digital thing come about? And that's something I was intriguing my thought.
Yeah.
And this is something very, very basic, but I think this is honestly one of the only things that we still keep through technology. And so I guess this is what we'd need to really focus off, but it's just simple electricity. Because one of the things that we haven't changed is we still have DC and AC. So direct current, alternating current power. We haven't come up with any new types of power. We haven't gotten rid of either of those two. Some things use AC, some things use DC. But other than that, other than just plain old electricity, I mean, think about the light bulbs. We've changed light bulbs so many times. Those change
LEDs.
so frequently. LEDs, right? They used to be cathode rays and stuff in order to light them. You had the fluorescent bulb, which is kind of going out now. Actually, here's just a cool thing to say. They say one of the only barriers visible from space. People say the Great Wall of China you can see from space. That's not true, apparently.
Yeah.
That's not true. You can't actually see it from space.
Yeah, I'm suspicious about that one.
Yeah, I mean, it's only however wide it is. So, sure, if you zoom in on Google Images, or on Google Maps, Google Earth, you can see it, yes. But that's not really seeing it from space. They say the only one you could truly see from space, or maybe there is another one or two, but one of the only ones you could truly see from space is the division between East and West Berlin, because the Americans, as they occupied, or I shouldn't really say occupied, but as they supported West Berlin during the Cold War, gave them Americanized light bulbs. I don't know what they were. I'm assuming some sort of fluorescent American-style bulb. The Russians gave East Berlin their bulb. And so from space, you can visibly see a distinct coloration difference between East and West Berlin at night.
No way.
Because of the bulb. I'm telling you, look up a picture right now.
I trust you.
I'll see if I can find a picture here, and I'll put it on the screen for you guys. It will actually use the video capabilities that we have on this podcast for something for once. But go ahead, take a look at that.
Would you look at that? The one side looks more like gold or something like that, and the other side looks more silver. That is...
I think if I remember correctly, I think west looks a little more silver, and the right looks a little more gold. Is that, or is it the other way?
The right is more gold.
Yeah, okay, so that is right. Because they say that like yellow light isn't really as good as white light.
Yeah.
That's why light bulbs aren't as yellow as they used to be. They're more white. And so Americans had better light bulbs at the time. They looked more white.
Yeah.
Russians had more yellow-looking light bulbs.
That is crazy. I never knew that.
Yeah.
That's giving new meaning to the term divided world.
Right.
Like, not even... Wow. That's so funny. Like, but that just shows you the advances in technology, because the Russian light bulbs had a less yellowy kind of light.
I think more yellowy.
Oh, yeah, well, more yellowy, yeah. Well, we had maybe a more advanced form of it because it was more silvery or even white, and it was...
Right.
Maybe a little brighter or whatnot, whereas the Russians had that. But that just shows you the importance of funding for these types of things and research and all that, because, I mean, we can change our way of life for the better if we put the time into it to actually do that. And just a little thing like light bulbs, like you were talking about, people cared about that, and they saw the original light bulb, and they wanted to improve it, and they wanted to make it better. And so next thing you know, we've got fluorescent bulbs, and we've got LED bulbs, and we've got all different types of bulbs that are more, efficient, maybe not look all that much different, but save money, save energy, which is really important. And, I think that's something that's kind of the same thing with space travel. People need to care. People need to invest. People need to spend time on it, and people need to really pay attention to it, because it is really important. It does, what comes out of it really changes our lives.
Right. And I mean, really, I guess the whole point of mentioning this light bulb thing is the point is, things do change very quickly. I mean, if you look, just right there, at that picture, you can very clearly, distinctly see we have one kind of technology, other people have a different kind of technology. And so if we're talking about something like space, it needs to be ultra compatible.
Yeah.
Nothing like, our phone is different, so we're going to have a different charger, so you can't use another company's phone charger on our phone. Yeah. I'm not going to let you do that. Or I was just looking at a keyboard power outlet. We need a new power outlet for our keyboard at school, or new power adapter, I should say, for our keyboard at school. And as I was looking into those, even the same company, they have an adapter that only works for like 3 of their keyboards.
Yes.
They have 2,000 keyboards, but there's adapters that only go with maybe 3 or 4 of them. Yeah. So it's not like, you could just go and buy an adapter and it works. And the thing is, too, it's not like one's providing more power or one's providing more safety or whatever. So it's like, this one takes this much power, so it needs this adapter. This one takes this much power, so it needs this adapter. No, it's not that.
No,
it's just that, sure, they're making new power adapters, and they want to upgrade their new keyboards with the new power adapters, but there's no reason it can't be compatible with the old ones.
Yep.
Think about it. I could plug anything I want into that outlet right there.
Yep.
Anything. Now, granted, British, or I should say European outlets are a little different than American ones, but basically, I don't know per se how long we've had this style of outlet, but I want to say at least like 1930s, 40s, we've had this style outlet.
The traditional 2 prongs with the one up top or on the bottom. Yeah,
exactly. So I could plug anything all the way from back to the 1930s into that outlet. I could take something today and time travel back to the 1930s, and I could plug it into their outlets.
Yeah.
That's compatibility.
Yeah.
And I really think, as I said, the only thing we truly see this in is just pure electricity.
Yes.
That's it. Just electricity itself, and how you plug it in.
Yeah.
We have new ways of making electricity, but we don't have new electricity.
No, because it's the same thing.
Right, and I guess that's because, it is just basically energized particles, yada, 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 so you can't really make new ones. So if we're going to do this, if this is going to be possible, we need to find a way to base as much as we can off of the simplest things we can.
Yes.
Energized particles, or radioactive particles, or simple stable particles, or compounds, or whatnot. Things that are just the way they are because of nature.
Yes.
That are as natural as possible, because nature tends to be the most reliable thing we have in terms of like chemistry.
Oh yeah.
And that sort of thing. Nature is reliable.
Yeah, and nature is very steady. Like nature, if as much as we do to it to try to kill it, it's very hard to do. And nature, it still survives and is very steady, very consistent. Throughout time as well. Kind of like you said with electricity. And we do need to make things that are compatible. You're absolutely right. We need to go back to basics. We need to look at say, okay, this is something simple like what you said with an energized particle. Okay, how do we use that to further our kind of larger mission? But it's really about the basics. I mean, you're absolutely right. I mean, I don't want to say this isn't rocket science because it kind of is. But it's true. We need to take a step back. We need to do research on simpler things before we go to bigger things, because that's usually how progression works. That's the kind of stuff we need to do, and that's really how we can start in the term of this next 50 years, like we started talking about. That's how we can really start with, okay, how exactly are we going to be able to do this? If we go back to a basic thing and we find a basic thing, then we'll be able to handle some of the larger issues if we tackle the simpler ones first. But it has to be a set order. It's not going to be a quick process, but we need to be patient. We need to make sure that we're crossing all our T's and dotting our I's with a lot of the simpler things before we get to bigger things, because that's how we'll eventually be able to go to other planets and do all this other stuff. But again, not going to be a quick process. I mean, I just don't see that happening. But it is, it's very possible, and as we've shown, I think today, it's very worth it as well.
Right. So I just a simple question of, is it possible?
Yeah.
Yes, or at least it will be sometime in the near future. So it's possible, or at least it will be. Now, really, the next question: practical. Is it practical? And I think we really hit this, a lot already.
Yeah.
Space exploration, if anything, is worth it just for the byproducts.
Yep.
Just for the immense technological development that we tend to get out of space travel as byproducts.
Yeah.
I think alone makes space travel worth it.
Yeah, no, I absolutely, agree with you when you say that. If you just look at the byproducts, it's really worth it. But then when you get into the other stuff, then you say, oh, wow, this is really, really worth it, with the chance to participate in something that not a lot of people are able to do, in the world, something like that. And there's really, even other than the byproducts, there's a lot of benefits to space travel.
Oh, absolutely. And I guess then, the next part of talking about is it practical is in, you got to kind of hit, well, from a financial standpoint.
Yeah.
Is it practical? Here's the one thing you can't, kind of sugarcoat about space travel. It costs a lot of money.
Oh, yeah.
A lot of money. And I mean, I guess part of like the joke, that people use when we talk about the Cold War, and as much as we joke about it, it's not so much a joke as that we went to the moon to bankrupt the Soviet Union.
Yep.
And that's what we did.
Yeah.
We went to the moon, and the Soviets tried to dump more money into their space program, and as they kept doing that, they drove themselves quite literally bankrupt.
Yes.
Just by putting money into space travel, and of course their military and whatnot too, plenty of money into that and their nuclear program. But a lot of it went into space travel.
Uh-huh.
And I think the idea there was America has no money to spend on space travel. We're getting the byproducts out of it. And even though it doesn't have a practical, strategical point yet, space travel, and they're talking about putting military stuff into space, but other than spying, other than for satellite purposes, which, again, we had those in the late 50s, early 60s. Past that, we didn't need to put men on the moon.
No.
That didn't give us a military strategy or a military, strategic sort of, leap ahead of the Russians by putting men on the moon. But it was because when we did it, they wanted to do it. And it cost them a lot of money. And that's where the strategy was it was running them bankrupt.
Yep.
because it does cost a lot of money.
Oh, yeah.
So the funding, not going to be easy to find.
No, it is not. However, there are certain ways, like, for example, if we just cut, hypothetically, let's say we have a huge military budget, right?
Yeah.
So if we took some of that out, put it into programs like NASA, SpaceX, or whatever, just general science funding, we could be able to help that. But even then, it's still not going to be easy. I mean, I don't know exactly how much it cost in the 60s, what you were talking about. I mean, you can look that up if you want, but for that time, it was a lot of money. And then 25 years later, the Soviet Union was basically gone. So, from that point of view, it worked for us, but it's not something that's going to be inexpensive. It's not something that's going to be cheap. I mean, there are probably going to be ways that they make it somewhat more cost-effective, in the next, 20, 25 years, 30 years, 50 years, whatever it winds up being. But it's a lot of money. It's a lot of effort. It's a lot of time. And that's not going to be necessarily an easy investment, especially with especially in America, because, in America, the people that make these decisions change every 4 or 8 years in terms of funding and stuff like that. So I think it's going to change, but we need to have a common interest in this. And then once we do that, then the people in charge are going to see the need for funding this type of stuff. And then that will happen, and then we'll be able to put more effort into this and have a more feasible chance of actually putting someone on, say, TRAPPIST-1 or any other planet, you name it. But yeah, it's very expensive, like you were saying. I mean, I don't know if you were able to find the exact number, but it is not cheap. It's a big investment if we're going to make it.
So I see here, this isn't so much the 60s, but it says the Space Shuttle Endeavour, the orbiter built to replace the Space Shuttle Challenger, which I believe that one exploded
in 86? That was
in
86. Yeah.
86,
yeah.
Right. So assuming that then they built it in, I would guess then the late 80s.
Yeah.
If they tried to replace it, would be my guess. So if we're talking late 80s, here it says 1.7 billion. That's for one shuttle. That's no gas.
One shuttle.
That's not gas. It's not the rocket fuel.
Nope.
Nothing like that. That's not even the booster that gets it to that's the shuttle itself. That's just a little plane that will eventually take them back down to Earth. So the booster that gets them up there, and then that they leave there too. And that's another big problem with space exploration, is it's kind of hard to recycle things.
Oh, yeah.
Other than what you land with, you're not coming back with a lot of what you launched with. All those boosters, whether it be solid fuel, liquid fuel, you really can't take them back with you.
No.
And that's why when people, think of a rocket ship, a lot of times they do. They think of that big, giant orange cone and the two smaller white cones coming off the side. That's not really the ship itself.
No.
That's the rocket.
No, yeah.
That is the rocket. And as soon as they get into space, all of that gets dropped.
Yep.
That's just to get them into space. That doesn't even get them to where they're going.
And get them back.
Once they're in space, doesn't even help get them back either. Unfortunately, once you're in space, no gravity, no atmosphere, it's a lot easier to get where you're going. You don't need that much fuel.
Yeah.
But even so, I mean, if we're talking going to different solar systems, that's going to take a lot of fuel. That is. And so...
And fuel is expensive as well.
Absolutely, yeah. So just the fuel itself, the fact that we can't recycle things like that, and that a space shuttle itself costs $1.7 billion.
And that's just one.
Just for the shuttle.
Yeah.
Right. I mean, again, fortunately, those we can reuse, but that's just about it. Obviously, you can't reuse the fuel, can't reuse the boosters, can't reuse the fuel tank. So, it's quite an expensive endeavor.
Oh, yeah.
But if we're talking about, the future of this planet, of humanity, you have to ask yourself, at what point does it become worth it? At what point do you find that we're in such a situation where you say, sure, it's a lot of money, but maybe we ought to spend it?
Yeah, and really that's the point we got to get to. We got to evaluate our planet in terms of how we're doing, in terms of how we're treating it. I mean, that's something we have to improve on, obviously. It sounds simple, but like reduce, reuse, recycle, all that stuff.
Right.
But seriously, and that's the kind of stuff that helps.
Right, lessons that people could actually learn from.
Oh, yeah. I mean, it's a simple thing, but it's really important. But yeah, I think the point, I think it's worth it right now. Personally,
I would agree with you on that. Absolutely,
I
would
just
say
just
start
as
now.
just as an insurance policy, in case anything crazy happens. It could be 1,000 years from now, but if anything crazy happens, we want to know. Okay, we can go here, we can go here, we can go here. We research this stuff and then we find that information.
Right.
And
we'll be glad we have it.
Yeah, and we'll be glad we have it because it's never bad to know more. It's never a bad thing to have more information.
Exactly.
Like, the president gets briefed, every day, right? And half that stuff.
Well, when he shows up.
Oh gosh. But he gets briefed every day, and I don't know how much of that stuff he actually uses in making decisions.
Right.
But it's something to know. It's something to have.
Exactly.
And we may not need it.
Knowledge can never.
Yeah.
I mean, I'm not to say it can never hurt you. I mean, you got all those crazy stories of people going insane from knowing too much.
Exactly.
But really,
it's called Twitter. No.
Yeah, God, the internet. Yeah. Literally. But the fact of the matter is, you're not gonna find yourself in a more dangerous situation because you know more.
Exactly.
If anything, you'll have better knowledge on how to get yourself out of a dangerous situation.
Yeah.
Because you know more.
Yeah.
It really it does not hurt to have more knowledge, especially on things. Yeah, if we're talking about the future of humanity, the future of our planet.
I mean, that sounds kind of important.
Right. This stuff is kind of the stuff that we want to know more about.
Yeah.
And if NASA's our first line of defense, then, I mean, hey.
We got to treat them like it.
That's where we want the money to be.
Yeah.
And I guess a lot of it falls into, well, where do you see, the threats? I know, like at the one of the Democratic debates about a year ago, question was asked. I guess probably over a year ago. Now I think last December,
probably,
November,
yeah.
right at the beginning of the whole election cycle, well before the primaries. Question was asked, what do you see as, this country and this world's biggest threat, biggest threat at the time? And, a lot of people said ISIS, Al-Qaeda, terrorism, that sort of thing, Russia, North Korea, yada, yada, yada. And Bernie Sanders, said the climate. And I think that's something powerful. And whether or not you agree with that, whether or not you agree that it's the most prominent threat, and I'm not saying I necessarily agree with that myself, because I don't think that it's the most first and foremost threat that we need to deal with.
Yeah.
But the fact that he'll bring it up there and that he puts it on the level of something of an ISIS, of an Al-Qaeda, of North Korea, of Russia, the fact that he puts it on a level like that, and when you think about it, it is. Because it has way more destructive capabilities than anything else that I've named, maybe other than Russia, just because they have the nuclear arsenal to blow the world up 100 times over. But other than Russia, and nuclear war is quite unlikely. But other than that threat, climate change and climate disaster has the most destructive capability of anything.
Yeah.
Right? And even if it's not the most prominent, most immediate threat, it's there. And I mean, this is something, we've talked about a couple times already.
Yeah.
You have to agree what we're doing to this planet is not good.
Nah.
NASA, if they're our first line of defense for stuff like this, as you said, we need to treat them like that,
and the thing is, you were talking about stuff like Al-Qaeda, North Korea. That's tangible stuff. Like Al-Qaeda and ISIS, ISIS engineers terrorist attacks all over the world.
Right.
North Korea, Russia could blow up the world. North Korea, they say they could blow up the world. Who really knows what they actually?
And they did a missile launch test this morning. Actually,
oh, they did.
It failed.
It failed. Okay.
Yep.
Yeah. I mean, they've said that they have nuclear weapons. Nobody really knows what they actually have.
Right. They don't know what they actually have.
They could blow up the world.
Maybe.
They could.
Yeah.
The climate, I mean, that's going to happen under our feet.
Right.
I mean, that's not something that's a tangible, like, okay, a missile is going to come this way and knock you off your feet and kill you. This is just something that's slowly happening, not
Right,
you
the
know,
water
taking
level
its
just
time,
slowly rises
and
until
then next thing
eventually
you know,
you're drowning. It's like they say, if you put a frog in a I don't know what kind of sick person did this experiment to find it out, but they say if you put a frog in like a pot of water, and you slowly heat up that water, just very slowly, incrementally, the frog will stay in that water until it boils to death.
Yep.
Because it can't change, or it can't sense the slight change. And I think they say that most likely the same sort of thing would happen with the human. Fortunately, no one's tried that yet.
No.
Or at least if they haven't documented it.
Yeah.
They haven't published it in a scientific paper. But that's very true. If it's something like an explosion, you see that.
Yeah.
It's evident. Global warming, as far as we're concerned, has probably been going on since the Industrial Revolution, and we've only just really started to recognize it in the 1970s. Is really when finally some people started to just to acknowledge it, and we still haven't even accepted it.
Yeah. And I mean, it didn't really,
as a culture,
it didn't really become a mainstream thing until Al Gore. And I mean,
until
that
Al
was
Gore,
2000.
right? 2000, and again, we still haven't even accepted it. We still have just about half the country saying that it's not happening at all.
Yeah.
Which again, whatever your beliefs behind why it's happening, sure, but it's happening is the point.
And then that's not a political thing.
Right, it's not. It's
like
just,
if you look at the trend, it's not a good trend. Like
right, and people even want to say, well, the Earth goes through cycles, it heats up.
Oh, sure.
Okay, well, even if that's the case, again, obviously dumping carbon into the air isn't helping.
Yeah.
And if we are going through a warming cycle that might kill us anyway, the last thing we want to do is help heat the planet up. That's the last thing you want to do. That's like they say, the worst thing to do in a fire is light a match.
Yeah.
Why do that?
It's like if you have lung cancer and the doctor tells you keep smoking.
Exactly.
Yeah.
Like that's just not. That's not. No. That's the opposite of what you want to do.
Exactly.
You want to try to prevent it as best you can, not add to it.
Yeah.
And so, and this is something we had talked about last week too, is part of the reason that we talked about fear. Is there a fear in the people in this country? In the Cold War, we had a true fear of the Russians, of the Soviets.
Yeah.
There were nuclear attack drills. People were afraid. Nowadays, we kind of lose that fear. Not so much that we don't have it, because we have threats. It's just that they're not as tangible. Connor made a very good point, and he said, if you're talking about the Cold War, you had a defined enemy. He wore a uniform. You knew him when you saw him, and he was your enemy. We could point to somebody. We could point to the Reds, right? The Reds, the Soviets, those dirty Russians. They are our enemy.
Right.
Nowadays, we can't point to people.
Exactly.
We can't just say everybody from the Arabian area, is a terrorist, because we know that to be not true.
Yeah, I mean, some of them are, but like...
Some of them are. Some of them aren't. Some of them come from completely different areas. We can't say everybody of the Muslim faith is a terrorist, because we know that to be not true.
Yeah.
Some of them are. Some of them aren't. Some of them are of other beliefs and of other creeds. So it's much harder to point to something definitively and call that our enemy. And so that's why, we don't have as much of a fear over it. And it's even more so.
Yeah.
It's even more so when we talk about the case of climate.
Exactly.
There's nothing you can point to. You can't point to the sun and say, "Oh, you're warming up our planet."
You can't flip the sun the bird.
Exactly. Well, I mean, you can.
Well, sure you can, but it's not going to do anything.
Yeah. I mean, if you want to, you can. That's something you can do. But as you said, it's not going to help at all. It's not helping.
No.
And you can, again, same thing. You can't go over to Detroit and find the Ford Motor Company, right? Or flip them the bird and hope that that's going to change their mind, on trying to make, first of all, their factories cleaner, and their cars cleaner, less pollution. That's not changing anybody's mind on anything. And again, you can't, even if you were to try to point to the things causing the problem, you're going to point to everyone. Everyone is a part of the problem. And when you have an enemy so broad as that and so undefined as everyone, can you even call it an enemy in the sense that you know what it is?
Yeah.
It's a threat, but it's not an enemy, because an enemy you know what your enemy is.
Right.
A threat, which this just is you can't define it at all.
Yeah.
You really can't, and that's to me what is so concerning about climate and whatnot, and I guess I think at this point we've probably done
Yeah.
a
I think
decent
we
job
have, but
with-
just one last point. I think it's interesting, if we like dramatically reduced our carbon emissions and we actually did the world some good. I would be interested to see what would happen to that trend.
That's true.
I think it might level off. You know what I mean?
I'll agree with you. I think
I'm
people
not.
say-
I'm not saying it's a hoax or anything.
right.
But
People are saying that we're going through a warming period as a planet, and I think sure, but again, if you look at it, we shouldn't be warming quite as fast as we are,
No.
quite as much as we are.
No.
And again, I mean,
And we're not helping it either.
Exactly. And my point will always be, you cannot argue that what we're doing is good. And so if it's not good, why do it? Or at least why do it to the effect that we are?
Yeah.
We should try to limit it as much as we can because we know it's not good.
Yeah.
We know that for sure.
Yeah. And the thing is too, like, who are we hurting? Ourselves.
Exactly.
So that's why
and
we gotta
who
take
and who
care of
are
this.
we hurting by trying to clean our act up?
Future generations.
Why was I'll say by if we attempt to try to fix this?
Oh, well,
who are we hurting? Really, businessmen and very greedy people
Yeah,
is who
and
we're hurting.
The thing is too, like, I'm plenty for manufacturing. Like that's
Right.
manufacturing is great, but there's a way to do it that doesn't kill the planet.
Absolutely.
Yeah.
Absolutely. Even if anything, they have just cleaner smokestacks.
Yeah.
That pull a little bit of the carbon and the other stuff out of the smoke when it leaves. Even just that. And really, the only pocket that's coming out of is a pocket of the greedy corporate businessman who owns the factory, who owns the company, and they're the people who don't want to pay up.
Yeah.
And I mean, this gets a bit more political. We got political in the name.
Yeah. Well.
So I think we have the right to mention that. But fact of the matter is if we try to help ourselves, we might save ourselves, and we're not hurting ourselves. Is really what it comes down to.
Yeah. So I mean, I think we've had a great discussion about this.
Right.
I was expecting this to go for like part of the show, whatnot, and we spent like a whole show on it. It was great.
Oh yeah,
Like
I love
I
this.
was like, that was really good, and unfortunately,
Yeah.
all good things must come to an end.
I think we're about running out of time.
I think we should probably wrap it up.
Right.
So
Well, I'll say in this case, we really only got to our first two questions there. Is it
Yeah.
possible? Is it practical? Next time here, I guess this is like a little 3-part discussion we're having here.
yeah.
Next time, I'd like to go into is it pragmatic, or how do we make it pragmatic? And then I'd like to get into for me what becomes the really fun stuff, the philosophy behind it.
Oh,
and,
yeah.
And this is a question I brought up before the show, just to get Jimmy thinking. And I'm going to bring it up to you guys now.
Yeah.
I'm going to give you a week to think. I'm going to give Jimmy a week to think.
I need a week.
Yeah. Don't we all?
Yeah.
But the question is, if you were in charge of this mission, if we got to go somewhere else, right? Either in charge of it from Earth, commanding it, or if you were there with them, if you were the leader of this expedition, what do? What first?
That's a great question.
Right. And this is assuming you found a planet, you're going to land on, and assuming it's relatively Earth-like too. We could assume it has everything that Earth has, nothing more, nothing less. It could literally be just a copy of Earth somewhere else. You're landing there. But really the question is, what do you do?
That's a great question, and I am going to answer that next week.
Yes.
So for my partner, Deaglan, DiMurro, Connor DiGiacomo, who is here in spirit, I am Jimmy Sullivan saying so long for now. We will see you next week.
Take care, everybody.